Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've spent a lot of time already learning how to estimate regressions, how to test hypotheses, how to compare models, and especially we've looked at all of the elements in a regression output. For instance, this is in Stata. We've learned this is the command and we start with y and then add all the other x variables. We have seen all of the elements separately of this table or this block of information in the upper left-hand side. We've also seen how they relate to the F statistic that is on this right-hand side, and then all of the other elements like the R squared and why do we need the adjusted R squared from the right-hand side. We've also seen all of the elements in this lower table in here, especially how we get the T column based on the coefficient and the standard error column, how the p-value is basically the one associated with the t-value in the t-value column. And we've also learned how to build the confidence intervals and how to double check like how these confidence intervals have been created in here. Reminding ourselves again that the default for Stata is the 95%. So if you wanted to change to a 90 or a 99%, then we need to do that manually. In this video, however, we're going to concentrate on the coefficient column. We have looked extensively into the t-tests and significance, so we can now very easily say whether what we have estimated is statistically significant individually and jointly. But all of these numbers that we're seeing in here, these magnitudes that we're seeing, what are they telling us? And the fact is, in order for us to be able to do these interpretations, we have to be aware that there are 4 different cases that we have to know before we make that interpretation. We're going to start with one of the simplest cases in this video, and then we're going to show the other cases in other videos. The first one is going to be what we will call the level model. And keep in mind for this, we're going to look like at a relationship between some x and y. So we're looking at the very simplest model, beta null equals to beta 1 x1 plus u. We've seen in previous videos that what we're trying to do is find the best fitted line out of all of the candidates. So for now, let's just assume that we have done this through Stata and we know this is the best candidate out there. And we know this is the beta null and we know that the slope in here is that beta 1 with the hats because this is what we have estimated. Now, when I have what I call a level model, what am I really referring to? Like, how can I look at this expression in here and say, oh, yeah, that's a level model. Well, a level model is where both the x variable and the y variable are in their original units. And what could be these original units? Well, they can be anything. They can be hours, they can be kilometers, they can be centimeters, they can be liters, they can be thousands of dollars, they can be pound per hour, and so on. So this is the unit that you have taken when you collected the data. And it's very easy to see that by opening your data set and looking at the descriptions of your variables or also looking at the numbers to kind of very clearly understand what the original units or measurement units of that particular variable are. Now, that is going to show like, or we are going to assume that this model is like expressed in the level way because we don't see any log transformations in there. And most of all, we have not done any other transformations like turning them into standard error deviations and so on. So no transformations. That would include also like square or cubed. Okay. So just levels. all right? And the key idea here is going to be the same idea you've seen in earlier math courses. This is a slope, okay? So for a slope, you know it's a rise over run, or the changes in y over the changes in x. So it's very easy to sort of see in here that the coefficient beta 1 measures the change in y when increasing x by 1 unit. So the only thing that is being changed in here is the fact that we have just a change in 1 unit in x, all right? And the way that we will say it is a 1 unit increase in x changes y by beta 1 units, basically, which is interchangeably the same with what I just wrote in here. You are not including any percentages or elasticities or any kind of interpretations or wording to that interpretation, okay? So imagine, for instance, that X is years of education and Y is annual salary in pounds. What that means is that your beta 1, the way we're going to estimate it is beta 1 tells us how many pounds does the salary see an increase for 1 additional year of education. Okay, so again, 1 unit, and we've given context because here X is years of education, is 1 additional year of education. And the increase that we're going to see in Y is exactly this beta 1. Okay, this is the intuition. And once again, keep in mind, units travel with the coefficient. Okay, with the coefficient. This is how you will start thinking from now on in terms of interpretations. In the next video, we're going to see how do we think of the slope as a constant marginal effect. We're going to see a little bit more closer the intercept as well, and a few common misconceptions that need to be corrected when we do the interpretation before diving into the mathematical proof for it. So stay tuned, and I'll see you in the next video.